everyone. I'm from Mesosphere also. think I'm the earliest engineer by now in Mesosphere still. And it doesn't say much. Like, we've been in business for 1.5 years. We have a lot of money. Oh, anyway, this is not going to be a gentle introduction to Mesos. So who of you guys do not know anything about Mesos? OK, Thomas, I believe you. So hopefully, like, the next talk can maybe give like a general introduction. But this is going to be a release where we talk about like new features, like things that are going to be added on top of Mesos. If you have any questions on the way, just feel free to ask. I'll do my very best to explain concepts, subsystems to you guys if you don't know them already. So what has happened during the last like 3 or 4 months? Well, about almost 500 patches later, and work from 37 hardworking contributors, we now have a 0.22 tagged release, and there's a lot of confetti. Like I like confetti, and we need a lot of help to test this thing. Ideally, and the reason that we're talking here today is that this would have been done by then, but that's how planning is. So before talking about all these awesome features that's going to go into Mesos 0.22, I want to thank all these guys who are like amongst the 37 people that have been working on making this happen. Amongst these 500 patches, there are 4 key things I want to talk about. And the first thing I want to talk about is this quotas. So far, like Mesos has not been able to isolate disk resources. So Mesos is a big bookkeeper of resources. So you can schedule on anything. You can schedule on bananas, you can schedule on apples. The Mesos slave will indeed pick up the size of your disk and announce them to frameworks. But so far, we've not been able to enforce the actual resources that people allocated of the disk. So a good cluster scheduler deals with orchestration and isolation, so make sure that tasks does not interfere with each other. And right now, Mesos supports like C-group CPU shares, supports memory limits, pit namespacing, in order for processes not to be able to see each other. And also when you shut down, so you don't get orphan processes outside of the Mesos trees. We have network isolation of port ranges and of bandwidth. We have like perf isolators that gives you access to performance counters per tasks. And now we also have disk isolation that you can enable. So the way that you enable it is just to, let's see, oh, I don't have a laser. To choose like POSIX disk. That will give you disk monitoring. And then if you add another flag, which is enforce container disk quotas, then Mesos will actually enforce those, this guy, enforce those limits. So the first step was like if you just enabled POSIX disk, then what you get is from the metrics endpoint, you'll get 3 new metrics that you keep track of, like how much of the disk, entire disk that's being allocated so far, and how much that's used. And if you enable enforcement of it, it will actually fail tasks and clean up their workspaces if they exceed their limit. So I have 2 examples here. So Mesos execute is kind of a helper program that makes you launch tasks in your cluster, or like arbitrary Unix processes in your cluster. Only launch 1. But what I'm doing here is that I'm saying you can have 64 megs of RAM, not RAM, but disk. But I'm actually writing 300 megs of file. And you can see that it tries to run, and then it will actually get failed by the slave. If I stay within my boundaries, I have like 32 megs that I'm writing. Things work fine. And the way it works is that it will periodically check how much disk that a task is using. And you can configure that interval. So let's zoom out a little bit. The next feature I want to talk about is compute node removal rate limiting. That's a long word. But what does that mean? I have a couple of supporting slides, so don't fear. This is a fragment of a Mesos cluster. I don't know if you've seen architectural diagrams of Mesos before, but you have frameworks on top, then you have a master, then you have many, many compute nodes that are running underneath. What Mesos does to detect failure is to ping different components within the cluster and ask whether or not they're alive. It's kind of ping-pongs or health checks that a Mesos master will send a ping to a compute node and ask, are you alive? It's like, yep, I'm alive. And that cycle keeps going. And it happens for all slaves. Because what happens when a compute node becomes irresponsive? The master node asks, are you alive? No response. And the master node will actually try to shut it down. Because the slave node might at that point have a different view. It might have connected to a different master doing a network partition. So for safety, the master will try to shut it down immediately, or when it reconnects, it'll try to shut down. But sometimes core engineers introduce some bugs, but also like doing some interleavings of network partitions that we might not have thought about. You might have a situation where the master node gets disconnected and thinks that all slaves have been disconnected by now. All slaves reconnect and are going to be told to shut down. That's a big scare if you're running twitter.com. So what we've introduced has been, not we, but the Mesos community, has been to introduce different mechanisms that prevents disaster. So obviously, while finding out these scares, we've figured out like the individual bugs and try to solve them. For example, a compute node guards against shutdown requests for a master that is not leading anymore. If you have a master that's non-leading that tries to shut down the cluster, that won't happen. Masters commit suicide where they lose connection to Zookeeper and lose track of state. Then there is a recovery remove limit. So if you run replicator log and a strict registry, then the Mesos master will keep track of all slaves that are supposed to be there. And if they're not there, or if slaves connect that are not supposed to be there, it'll try to shut them down. So there is a safety guard where you can say, if you pick up that you're about to shut off 75% of your entire cluster, something is wrong, don't do it. So that's already there. That was in there before 0.22. And now we have remove rate limits. So what does that mean? Actually, I have a movie to support this. But that means that you can give a number of slaves that are allowed to be shut down over an amount of time. Let's see if this is possible. So I have a version of Mesos that is terribly broken right now. So I've purposely introduced a bug where the master will never send any pings, but expect them to be responded, which means that it will eventually or effectively shut down the entire cluster. So I'm starting a local cluster just on my own box with 50 slaves. Let's see if you can see this. And everything is going to be shut down. Let's see if I can pull this over so you can see this a bit better. 0 slaves got the chance to connect. Everything has been disconnected. What I'm trying to do now, let's see, as you can see there, is that I'm saying that you're going to at most shut down 1 slave a second. So see, from our 50, it will slowly decrease. So if you have monitoring around this master, you'll figure out that it's doing something that it's not supposed to, and you can shoot the master in the head and have another master come up and recover from these kind of scares or failures. Next thing I want to talk about is task labels. So what are they? Or more appropriately, what's the problem? The problem is that we need to tag the tasks that we're running our cluster somehow. That's something that we've been discovering from people that have been operating clusters or people that have been writing frameworks. And traditionally, people have been encoding this in weird ways. Like, for example, just calling their task names very clever things like Cassandra, prod, foobar, apples, bananas, task 1. So before, I don't know if you're familiar with this, but if you launch things in a Mesos cluster, you use task info to tell Mesos what to do. Like if it's to launch a container, if it is to start a process. But that's not too important right now. The important thing is that we've added 2 more fields to this task info. One of them is labels, and you can put in arbitrary key value pairs. So how is this different from data? Because data is also a field that you can set, a framework can set. These labels will be available through all state endpoints, so from the master and the slave. So this becomes a way of effectively tagging your tasks running in your cluster. So see here, I gave something that was a bit more clever. It said that this is a task which is in the environment production and also has some apples and bananas. Next big feature is it's not switching gears entirely, but it is a little bit. So first off, I found a picture of like awful butcher hooks with blood on them. So I thought it would be prettier to find like a decorator of painting a house. So here he is. So what's a hook, by the way? So we recently introduced something called Mesos modules, which is a way to replace full components within Mesos. So basically, you could load a dynamic library, which provided an implementation, a full implementation of something. It could be isolators, just like the disk isolator, whatever you saw. So you could do like third-party proprietary isolators. It could be, give you a good example. Authentication, if you have external or third-party security subsystems that you need to support. And also resource allocators. If you have different resource strategies or allocation algorithms that you want to try out, like opposed to DRF, which is like the effective one in Mesos, you can experiment with those with modules. So a hook is supported as a module, but it doesn't replace full subsystems. It's more like an event callback across library borders. So you could be notified when certain things happen. And so far, we have 3 hooks. It's not too much. And it is the master launch task, a slave executor environment, and slave remove executor. These things are all internal to Mesos, so probably not too familiar. So if you look at how a launch test sequence would look like, the framework issues launch test request to the master asks the compute node to run something. So you get a chance to tie into this sequence. So the master launch task label decorator is being called on the master node, and the slave executor environment decorator is being called on the compute node when the run task request gets in. So one way, decorator, you saw decorator, right? So this was called something something label decorator, something something environment decorator. So a decorator is a special kind of hook because it has a return type. So what does that mean? It means that it decorates the object that is in transit. So if we go back, oh, actually, I have another figure here. If you look, this is the same figure as before. This means that you can hang off new things of the object going through the system. For example, this is a task info that's going through the system. And here with a task or launch task label decorator, I'm hanging off like new sets of key value pairs of the task info. And on the compute node, you have a chance of actually injecting other kinds of environment variables that need to be set up when that executor is being run. So that's a pretty powerful feature, but why are we introducing it at all? So this enables like a ton of things. You could do service discovery systems with it. You can implement security subsystems. You can keep track of resource accounting. You can trace your tasks throughout your cluster, and just like write a ton of tooling around this. That's what we were using it for. So these were like 4 big things, but there's a lot of things that didn't get to mention. There's like explicit status update acknowledgement, which becomes very clear when you're running very large scale systems with many, many tasks that needs to get their status updates acknowledged. Anonymous modules, service discovery features, external log files, configurable GC headroom, and tons of fixes. So this feature, or this release, also introduced some changes. For example, if you have tooling around stats.json, it won't work anymore. It was deprecated over 021.1. So now there's a new one. It's called metric snapshot. And it's even nicer because everything is sorted in this nice way, and it's the same way that you access statistics across masters and slaves. Another thing is that slave checkpointing is now always on. So you don't have a slave checkpointing flag anymore. In the upcoming releases, so 022 was supposed to be the SSL release. We didn't get all of it done. That's SSL. I skipped it a little bit. But this will come up in 023. We are actively working on persistence primitives for implementing storage systems on Mesos. Dynamic reservations, so you don't have to chop up your entire cluster ahead of time. Optimistic offers for offer parallelism. And allocated modules, as we mentioned before. And that was basically it. I think you should get involved. You should come and try the RC out. And come out, hang out with us. So do you guys have any questions? Other than where I found this awesome GIF. Yeah, but very early on, yeah. I'm trying to get back to that haircut, though.
What's your favorite feature of this release?
Actually, so I went through and tried all these things in order to tell you guys about it. On top of being the release manager, so I should have done that like way before. I think like rate limiting of different subsystems is going to be more and more important when you run these things at scale. It's things that you don't notice when you're running, let's say, 10 or 100 machines. But if you want to pick up scares that could basically put you out of business, then I think it's pretty important feature.
What happens when you hit the limits?
So it just schedules, it delays things from happening. So it will still happen if you don't stop it. It will just be slower.
But that's what the other limit was for, right? The percentage removal limit, that will cap how many you can actually remove.
Yeah, but it's also there are many kind of interleavings where bad things can happen. And this particular number is doing a master failover, where I would say never kick off more than X% of the entire cluster, because then something is probably wrong. Yeah?
Couldn't the master itself detect that it's doing something stupid and commit suicide?
We're trying to do our very best, picking up different kind of indicators of it being in an ill state. Let's say if it loses connection to Zookeeper for too long and has a hard time reconciling its state, then it will commit suicide also. Alex?
You said that you introduced labels were introduced in this release, and they will pop up in master endpoints. If I would like to put sensitive information into these labels, can I somehow hide it from master endpoint?
So that's the semantics of decorators are going to change in 023. So decorators can also remove things. So it's a good point, because if you want to use labels as a carrying mechanism, then you might not reveal it over as an HTTP endpoint. So there's an upcoming change where you get the possibility of removing things from the environment from labels. Yeah.
Are the nodes also labeled, or is it just the tasks that are labeled?
Nodes in terms of compute nodes?
The slave nodes, basically.
Yeah, so they have attributes, right? So that will already hang off the resource offer when it gets to the framework. I really hope that we can use labels like everywhere. Like I would love to see labels on status updates, right? So when status updates go back through the master, that you can actually tag them somehow. So you can write more and more tooling around this. And that's where like things like the resource accounting becomes possible, where you can like bill individual organizations and saying you've been using this much compute in a very, very precise manner. Cool. Thank you guys.